Being able to change or select particular genetics of a person before they're born is no longer science fiction. And new developments show that it could be a life-saving reality for some families. Also opens the door to all kinds of ethical questions, which we'll get into. Here are the details. Earlier this week, we told you about 8 healthy babies born in the UK who had the DNA of 3 different people, done using an experimental IVF technique not legal in the U.S., which we'll also talk about. Here's how it works, though. In addition to the mother's egg and the father's sperm, a donor, a second woman, supplies a strand of healthy mitochondria, makes up less than 1% of that baby's DNA, but that is enough, researchers say, to prevent mutations that lead to potentially deadly rare diseases. So, back to the questions here ethically. If you're wondering why it's not legal here in the U.S., it's because our Food and Drug Administration enforces a ban on research that involves genetically modifying the embryos, which is what that is. However, in this country, it is legal to screen embryos before selecting which ones to use for IVF. And for years, families undergoing IVF have used screenings to identify embryos with certain types of single-cell mutations linked to diseases like Down syndrome or cystic fibrosis. But now, some Silicon Valley-based startups are leaning into embryo screenings and pitching testing that they say can identify a wider variety of traits and potential abnormalities. That raises the ethical question of, are we going to have a super generation of babies ethically selected to be a certain way? Can we do that? Should we do that? To break it all down is the exact right person, Professor of Medical Ethics at New York University, Arthur Caplan. Professor Caplan, thank you very much for being here. By all means, take issue or expand on that introduction. But please also help me understand, with this case in the UK, what it tells us about where the guidelines or parameters should be as we think about what we should do beyond what we're capable of doing.
Hi, Tony. Adriana, thanks for having me. Well, there's a lot going on in this area, but let's just look back at this therapeutic procedure that was reported out of the UK with the 3-parent babies. Think of an embryo as a donut, and inside the donut hole is where all of the DNA resides that makes us who we are, whether it's Hulk Hogan's appearance or somebody who's going to be tall or short or skin color. It's all in that donut hole, except for one tiny speck of DNA, which is the battery pack. Every cell needs energy. It can't do anything, can't divide, can't grow, can't go from embryo to person if it doesn't have, if you will, electricity. That's what got transplanted in the UK. It's not the traits that, if you will, make us who we are. It's the energy cell. It's like moving a battery in a toy where the battery has run out. It doesn't really change the nature of the toy. What they changed was putting in a new battery, letting the toy function. Does that make sense?
Yeah, it does, Professor. But then it also raises the question, if we can do this now, in the not too distant future, we might be able to make a child taller or have a fuller head of hair, or you name it.
Well, yes. However, not yet. The mitochondria experiment's pretty primitive. It's pointing towards saying we could genetically engineer or change embryos, or, as you pointed out, without even changing them, maybe screen them, just do genetic tests, pull a cell off the embryo at an early stage, analyze its DNA. The problem right now is there's too much hype. We're not really there yet on the science side. We don't know exactly what the contribution is of many genes to making you tall or smart or athletic or whatever it might be, a violinist, whatever it might be. And we do know, every parent knows this, same parents, same genes coming in, they have a family, kids turn out very differently, right? Even though a lot of genetic commonality. So environment and what you eat and things that can happen accidentally, diseases, they shape who we are too. Are we going to head down that road? That's the question. And the good news is this little mitochondria experiment is an early warning signal to say, if we want to restrict this, we better do so now. Now, it is illegal, as you pointed out, Tony, in the US, even to do this primitive mitochondrial transplant, which I think is wrong. I think that line is in the wrong place. But down the road, do we really want wealthier people saying, yeah, I'll make a perfect baby and a smarter baby and give that kid a tremendous advantage over others?
Professor Caplan, I really appreciate this conversation. It is early. Not everything is possible yet, but as we move closer, you're going to be in demand as someone to help us think about what diseases we can't live with, and then what issues we'd prefer not to live with, and whether or not we play God in determining that what it is. So thank you very much.
And there were some cute babies in the background there we could see in the window.
Oh, we missed some kiddos?
Yeah, there were cute babies
running around here. I didn't engineer them, though. I didn't engineer them.
All right. Thank you very much, Professor. We'll have you back again soon.